that makes sense. Start npm because it's really the only place where I know where my code is. Like, okay. Come on. Or even, okay, I will do it differently. Let's see, where's my presentation? It was somewhere here. Projects. It was the Kotlin Spring. This is the presentation, okay. And, oh, actually you can't really see that well, but we'll fix that. Hopefully, well, Windows npm works. Okay. Sorry for the delay because of technical problem. That was quite funny. What happened? Okay, so today I'm going to talk about Kotlin and Spring 5 together. A small subtitle is 2 small steps. The real subtitle should be like lies. How to lie, practically. So, small lies that can save your life and project. Like, okay, on a small scale. So my name is Ratajski and work for Ingenious GmbH in Switzerland, doing, this work for banking and insurance companies. I am a Java developer, and I spend my time still mostly with Java. So what I do at this conference, I don't know. And however, I have like functional experience with functional programming, and I try to do functional programming in Java, which is fun. Okay, so the story today started with a project for one of our customers. And this project, it's, okay, one thing is disclaimer. I always try to see. If you see hear some success story, be aware that, small good team can work efficiently on everything. And we are a small team and we are experienced people. We are even efficient with Scrum, which is normally not the case. So the story about the project is printing. So the Switzerland is like a funny country where they have special protocol. You normally use, when you have something in web, you use HTTP or HTTPS. They have special protocol, practically. It doesn't have name, but would be the best would be HTTP plus P. It means that what does it mean in Switzerland to fill online form? Like you want to do online insurance, or you want to start online bank account. Typically, it works for all companies the same way. You press a submit, and then pop-ups that the next day you will have a mail in your mailbox down there, and you have to see what's there and basically submit it via normal post. So it's like extension of HTTP with a snail mail, this really old mails. And it works perfectly. Maybe one day at 4 p.m. I'm pressing submit on something. Next day in 8 in the morning, it's there, really, the post. So it's like a little bit slower than most of the responses from web, but it works this way. I know there are reasons for that, legal reasons, but it's not about that. But a lot of companies have this big printing machines that basically like print hundreds, thousands of mails every day, and they are delivered across the country because this is this extension of the protocol. It's like you do something on the web and you get a mail. So we had to implement one of the systems for one case. So basically, we can summarize this system is just big PDF processing. We get PDFs, we mark them for printing because we put special marker on each page, which basically to the big machine says where to put this page in the envelope, who is the addressee. There are special systems for that, but really automated. So you do on the server, you prepare these PDFs, and then machine really prints it, sorts it, and just goes to the lorry. It's delivered across the country. It works perfectly, really, even better than normal HTTP. Okay, so the interesting part of that is about PDF processing, because it's like process that it consumes a lot of memory. We use some external tools, libraries that are not really reliable, so like they fail a lot, especially, for instance, converting something to PDF-A format. And our customer in that case was using the old infrastructure. Okay, infrastructure for Java EE, but it's now exactly in the moment of changing to the new infrastructure. It is not yet decided what. There are a couple of options, but they are thinking about not doing everything on application servers. And it had to support basic monitoring and management. So After we've seen this, because this PDF processing is just like stream processing when you have to put throttling on the memory, or you have to repeat some steps because they may fail. It's like perfect case for reactive streams, like exactly, like this is this. That's our application. I will later show you. It's like part of the code which exactly does the moment process, and it's like typical processing. Even in some parts, back pressure and stuff like that. But so I would think maybe, okay, Scala, okay, streams, that would fit to that. It will be like small projects. So this project, by the way, isn't really big. That's whatever project I do, it's typically very small at the end. So reality is, however, and it happens a lot in my projects, that those companies have standards. And standards are, for instance, the typical Java standard. Who knows Spring in Java? Great. Who loves Spring in Java? Whoa, great, the brave people. Okay, so this is the business in Java, and we have Spring framework. This is the enterprise. And this even the Spring and Java EE have same roots. So you may even work on something called JBoss WebSphere, and then you put Spring there. And it's really application servers. Who worked with application servers? So you may read that they were considered obsolete like 5 or 6 years ago already, but still companies do development for application servers. Nobody knows why, but they do. Okay, and this architecture has some limitation. First, it's a blocking architecture typically, so you have one request, one thread, this classical model. Funny thing is the aspects, so that there are aspects, so security transactions. I will cover this topic a little bit later, but I call it like runtime magic. So whatever happens on these application servers, it's really provided by runtime magic. What is this runtime magic? Just look at this code because I really like it. It really happened to me not once. If you want to do a transaction on a database, in I would say the normal way, you would start a transaction by begin. You would do some inserts, updates in the database. Then you would do commit. In case of some failure, you would do rollback. In Spring, they are very smart. They tell you just put this transactional annotation on top of the method and it will be done. So the thing is how it works. How does this transactional annotation work? Who knows how this works? Oh, great. So tell me one word. How? Yes. And with use of what? Dynamic proxy, exactly. So basically it's like Spring starts, scans all your classes. Because of that, it's very fast. It's like can take like 3 minutes to start small application. Scans everything, says, oh, here you have transactional. So for this class, I won't be really instantiating that class. I will be instantiating the dynamic proxy. Then I put some aspects, so runtime checks for the transactions, and it would work. However, sometimes it wouldn't. Why? Because maybe after refactoring, it happens. You know that it works only with dynamics proxy on public methods. But after changes, so everybody would put it on only on a public method. But sometimes you do refactoring and you change something public to private, and then it stops working, which is cool because now you have method that's supposed to run inside of transaction, but it's not, which might lead to some troubles. Who knows what else can happen? Okay, this is not a conference for blaming Java EE and Spring, but there's even more funny thing. It works only if you call this method from a different class. If you make a self-call, so one method calls another, this transactional will not work. That's the problem of dynamic proxy. This is really cool because it's really not that easy even to spot. What's more funny, it only works if in fact the class was created, is managed by Spring. So if you accidentally, and what would prevent you from doing that, instantiate class on your own, calling it with a new constructor, it will not work. Because in Spring you are not allowed to use new. You have to really like tell the Spring, please construct me instance of this class and etc. But you might forget about it. It's easy. Or, this is really funny, we now have more cores, why not to use them in executors? So you start some executor service, you call it, and it's inside of thread, and now it stops working because this transaction stores context in something called thread local. which is basically global thing, but global for thread. So if you skip to a different thread, it will be lost. It's even more funny because maybe the other thread will be associated with other transactions, so now mixed transactions. That's cool. And this happens, it happened to recently to one of the applications I'm working on. I just realized that we don't have transactions on production since over a year. That's like, I was just doing extensive tests of something, and I wanted to prove that my code for concurrency, for working on a cluster environment is really safe. But it appeared not to be. So I was looking where I made a mistake. And the mistake was that this transactional, that is basically core, every transaction was covered by this. So it wasn't working. Why? That's the thing I learned. I forgot it. Basically, JVM, if you look at Java annotations, treats the annotations as something supplementary. So if the transactional class is not available on the class path during the runtime, it's just ignored, as if it wasn't there. So even though Spring had no idea that the class had this annotation, so it couldn't scan it. It was scanning, oh, there's no annotation at all, because it wasn't there. It wasn't instantiated after the class was loaded by the bytecode loader. So it's nice. Oh, of course, you are allowed in the Spring to create your own aspects. And people do that. I was doing that. And your own aspect can, change anything in the. So maybe you say that with every method call, it's easy to do in a Spring. I maybe change all integers and add one to it. Or if I find there is a transaction, I automatically commit it, whatever. You can do that. And of course, mostly you don't have evil developers in your team. But sometimes you might forget about something, and it's best because it's scanned. So you look at your code, and maybe you would attach third-party library done by some other team, and it's there, this scope, this aspect. And it will be automatically run. It will change the way your code works. And the best thing, in tests, everything will be perfect. So during the tests, you start a little bit, maybe different classes. You have different things in a class loader. So you won't see any problem. So for instance, for this thing, we had tests, really good tests, but we had different classes. This is normal during the unit test or whatever, like integration test. So I only try to repeat that no serious business should ever use things like Java EE, that's basically the same, or Spring on production, yeah, and rely on Runtime Magic. However, that's exactly what they do. So why do they do that? By the way, it doesn't mean that Spring people or this business is completely stupid. There were historical reasons why this framework evolved. It was really good. It was the best we had like 10 years ago. And it evolved that time. It was shaped that time. And since that, we have now better alternatives. But nobody is really, okay, not nobody, but business is afraid of doing the changes. So they keep, okay, this works. There are sometimes problems. We have to stop development for 2 months because we are tracking some runtime problems, but mostly it works. So, and this is the problem of the IT mainstream. But basically, we don't do big steps. So that's my examples, like C++. That was my, one of the languages I coded a lot. But at the moment I switched to C++ and the industry, in 90s it was like dominating. Was it the best object-oriented language there? It wasn't. There were better alternatives, but people and the industry was choosing C++ because it was a small step from C. Not that big, so they were not that much afraid. So they could continue write almost C, but with some small improvements. It's the same with Java success. Was that Java at the beginning of this century the best object-oriented language? Probably not. But it was very similar to this already adapted C++. So this is the pattern that, even for instance, in old story, you see that Unix became popular, but after, first there was the system that was really innovative, Multics. And it was never really widely accepted, but people slowly seen some improvements, and then they accepted something that was a little bit worse, but more they were more used to that, and it was, for instance, Unix. So you see that. So basically, we as industry do baby steps, like small steps. Even when we have better options, we are afraid of that. We have to embrace. This is the thing I am aware, and I'm trying to use it. So cool stuff. Last year appeared a new version of Spring called Spring 5. It was released, and this is just the new version of Spring, and this is the most popular Java enterprise framework as for now, of course. And if you look at the story of Spring, there was a Spring 2.0. That's the first version I really played a lot. It was like programming with XML. At that times, people were really like making jokes about Java programmers that they spent their time mostly in XML. That was exactly the case. I was doing that, and I even was thinking that's exactly what I should do: write more XMLs, because touching Java is scary. Who knows what might happen? Okay. Then someone said that, oh, maybe the XML isn't perfect. Let's move all of this XML to annotations. So that's the story of annotations. Basically the same XML, but you just put it into the code, which is so much better right now. This is one of the best pages I know. Annotation Mania to be honest, I've seen on production classes that really make this a shame, that they really have pages of annotations. That's not a joke. I'm not allowed to show them, but that happens for real. Okay, so and then appeared the Spring 5, and the thing, all this crazy stuff works. So, but it has one module called Spring Web Flux. What is this Spring Web Flux? If you know something like HTTP, Node.js Express, or Ratpack, or even Vertex to some extent, this is the functional framework for doing routing in web and doing this the clean way, without annotation, without servlets, etc. How does it look like? You see the sample on the screen. This is the normal Java code that would work the same on production, on tests, everywhere, because nothing can break here, nothing is scanned. It's just plain Java, real plain Java. And this is from one of the examples. So we don't have servlets, we don't have scanning, we don't have aspects. We can use that. So no more magic annotation, which is cool. And it uses inside, it's already built on top something called Project Reactor. What is Project Reactor? It's like, who has heard about this? This is, in Java world, the Akka streams implementation, but just reactive stream implementation for Java, yet another. And maybe RxJava also. So yeah, and WebFlux is built on top of that. So it means that we have things like Mono and Flux. So Flux is a typical thing that you know as flow or flowable or observable, whatever. This is the same. And Mono is just a special case where you only expect maximum one element. Because for instance, if it's WebSocket, you will return Flux. If it's just typical get or whatever, you return Mono, because at one moment you will get maximum one object as an answer. That's it. So I am not here today to describe you this framework because it works. I told you it's about lice. I'm not going to repeat the documentation for that. So the truth is funny. This web flux has absolutely nothing to do with Spring. It's just Spring in the name. And I even call it Spring without Spring, because the thing you have in Spring is typically Spring context, where all those, spoiled classes with these aspects are kept. It is something global. You have these aspects. Specifically, you have those beans. Nothing like this is needed, and you don't have to use that in Spring Web Flux. So it's completely new framework. And however, it supports these ugly parts. It's to some extent you can work with new plain Java Spring Web Flux and use the old, I call them ugly parts, but you can avoid them, yeah? To the moment that someone will use them, because you still have them on the dependencies, so anyone can just use it, and sometimes you wouldn't even notice. Like for instance, Spring Data. This is a very popular framework in Java that's like, if you want to see ultimate magic in code, something that would scare you to death, it's look at how Spring Data works. I don't say, okay, it scares me, but it works. It's really widely used. I won't spend time blaming Spring Data. I'm even sometimes using it, but okay. So this is about Java, and I already did a couple of small projects with Flux and Java. I also did small projects with something called Ratpack, so it was like less popular library for doing functional web servers. And the thing is that, for instance, Ratpack never had a name Spring, so it never became very popular, but Flux has a Spring name, as I said, so it becomes popular right now. And it works with Java, and we can have this purely written functional servers. But how the functional programming works with Java? Who has tried it? Writing functional code with Java? Raise your hands. So it works. Yes? So do you miss something? So what do we have in Java that supports functional programming? Lambdas. What else? Okay. Lambdas are very important, but if you write especially immutable code, like you want to embrace immutability, that's like, for me, the core concept of functional programming. It's like nothing really in Java helps you in that. So maybe we should use Scala. That's, for instance, I'm a Scala fanboy. For my small projects typically I do them in Scala. I'm not a great Scala developer, but I just find it useful and I like the language. And the Scala has, however, a problem. People consider it very complex. And it is complex language. It is. That's the thing I am facing. Every time I'm just proposing, let's use Scala, that people, no, I only hear bad things about Scala. It's every team that chooses Scala fails instantly and blah, blah, blah. I feel it. I hear it from developers, I hear it from managers, and it's like, what? Because Scala has implicits. That's, and now the funny thing, people that use Spring, the classical one, when one small class deployed somewhere on the class path can change the way the whole application works, are afraid of implicits that are only checked during the compilation, and in case something doesn't work, you will get the compiler error. And in tests, you will have the same implicits working, and you will check them. So it's like, what? Okay, but that's the reality. I'm talking to such people. It's just, okay. So maybe we should choose something else, less scary. That's exactly the Kotlin. So what's the difference between Kotlin and Scala? That's classical example. It's who had seen a Java bean before? So we have this document with ID, path, and type, whatever it is. And then we have setters, getters, and then ton of other stuff. I will describe it later. So the cool thing is that we don't write Java beans anymore. Okay, that's a thing that changed in the last years. Slowly, the Java developers became convinced that Java beans isn't the best idea aren't the best idea. So now we would write it rather this way in Java. We have 3 final public fields. Why not? They are final. So we try to do immutable objects. We have a constructor that really constructs something ready, not that we construct object and then we have to set a couple of things. It's like, and then we typically have to provide equals, hash code. Who knows what the hash code is for? Great, so it's like, if I would write here return 1, would it be a good hash code or not? Yeah, so the thing about hash code is you have to know what are you using it for. So if you have limited number of instances, the return 1 is quite okay. If you put them in a lot of hash sets, then of course you have to provide something like more performant. But it's like, so you provide a toString methods, and finally, because maybe you want to change the object, you provide this kind of a with constructor, so copying, but with a small changed element. So that's how much code I have to typically write in Java doing immutable code, immutable stuff. Like, it's a lot. In Kotlin, it's like this. And if you know Scala, you know that you change it to case class and skip the vals, and it's the same. So it's nothing new compared to Scala. But it solves all those problems. So it's okay. This is the basic stuff that already helps a lot. and you use it, for instance, like you create a new document using the old. Who has seen that it's very similar to Scala? Is it? It looks like Scala completely. This line is perfectly like in Scala. It has vals, so you can skip the type because it's inferred. You see that mutation is not allowed. Compiler will check that. Of course, it also has vars, but they were never interesting for me. So if is an expression in Kotlin, exactly as in Scala. So I can have a if and assign it to variable. And all other constructs in language are expressions, so the loops, etc. So they can return stuff. It, to some extent, uses pattern matching. However, for me, pattern matching was never that crucial, in fact. Even in functional programming, I'm not using it that much in Scala or even in Haskell. It's just, in Haskell, you mostly have to do that. In Scala, I'm not using it that much. But and in Kotlin, the pattern matching is very limited. So it's like, you mostly will be disappointed if you try it. Okay. Of course, it has lambdas. I would even say they are a little bit, for me, I like them a little bit more than Scala ones, but nevertheless, there is not a big change. This it is underscore. So this is the default argument. So it's like underscore in Scala. And it has one thing that, for instance, Scala doesn't have. So this is the short story about Kotlin, what's there. Null safety. So Scala solved a lot of problems, provides us really a lot of cool stuff, but it doesn't solve fundamental problem of JVM, the nulls. And Kotlin, to some extent, does it. You see here this string question mark. What does it say? This particular, and only this property, the path, may be nullable. So you can put a null there. You can't do it with this ID, you can't do it with this type. Only the path can be null, and you can construct this document with a null. So it's built in a language, and you see you can construct a special type string question mark, which means nullable. So for instance, if I want to take this path and assign it to the string, the compiler will say, no, you have string question mark nullable, you can't assign it to the normal string, because normal string can never have null. What you can do classical null checking as in Java or in Scala. And if you do null check, compiler will see that, and then will let you to put the value after this check into the string, or you put else. Same if you do some, for instance, things like length on this, it will not compile. To let you compile if you use if, or you have a special operator like question mark dot. So basically it's with null checking, which is funny because if it is null, the len will be null finally. So the type of this len is integer question mark. But okay, and you have even special operators. There are more of them, like Elvis operator, which you might realize how it works. So I like this. This is the practical, very pragmatic thing. Yeah. Oh, it's totally okay. It is different because it uses the JVM null internally. So it's like if you work, for instance, with a Java code, you can easily use this null checking. But I'm not covering this part that much. It's just a safer null. It's not option. But the thing is it better than optional option? And I say no. The answer to that is in my code, I'm using option mostly. Option from Wave package that it's like, because this Java optional that you have in Java 8 is broken for me. So I use option. There's a special package for Java called Wave library, which basically mimics the Scala collections, immutable collections. And it has option there, and I'm using that. And I prefer that over this built-in Kotlin. However, I have sometimes doubts. Maybe I should use the language. I have more doubts like this. Kotlin also has some own lists. That's the same story. It supports lists to some extent with a syntax, immutable and mutable lists. And even today I was trying to check it because I don't use them. Again, I use the standard Wave lists, which have nice API, the same as in Scala. And the cool thing is they work perfectly with Java also, so I know that I can always exchange this code with Java parts easily. So mostly I don't use those two features of Kotlin. I use the standard libraries with immutable collections called Waiver. I'm using Waiver also extensively in Java, basically. So that's, but I have doubts about it. So other people are using this now or using built-in lists. Okay, one thing, because Kotlin has a lot of, already we have really rich ecosystem for Kotlin. Things that they are really designed for Kotlin. Like Kotlin has own framework, which looks like HTTP, which looks like Spring Web Flux, which is called Ktor. Exactly this. I even work with that. So it just uses more the possibilities that Kotlin brings. But again, I'm not using that. I'm using Spring because it has name Spring and it sells better to my management. Simply like that. Okay. So the conclusion here is, even though Kotlin has some limitations that I will tell you later, it supports immutability and expressions just way better than Java. It's practical. So if you come from the Java world, Kotlin is something like a Java++. And it has a great advantage. It mixes with Java perfectly. So both ways. You can use Java code in Kotlin really easily. That's not a problem for Scala, for instance. But vice versa, you call the Kotlin code from Java also without any problems. And that's funny. If you have a Java developer, in 15 minutes, he can be a Kotlin developer, already quite efficient, really. It's just not a problem at all. The syntax is very easy. However, you come from Scala, it is just Scala minus minus. I really call it mostly. It has no implicits, it has no macros, no type projections. You don't use them probably that much, but sometimes you find them handy. Basically, the type system of Kotlin is just Java type system, has nothing sophisticated. This really annoys me. Kotlin has only global type aliases, so I don't like it at all. No for comprehension, so it means you have a flat math if you use some monadic code in Kotlin. And Scala developer will just see Kotlin and already can work with that in just 5 minutes because it's just limited Scala. However, it will just annoy you every couple of minutes. That's my work with Kotlin. It annoys me, really. Like for not being Scala, because there is, for instance, this no for, there are no type classes. However, the Kotlin is right now still in development. You can vote for features. And there are people experimenting. So I still remember, I don't know the story. At that time, I wasn't Scala developers, but initially, people were thinking we have no type classes in Scala, but then someone showed how to do that with implicits. So exactly at this moment, there are some experiments how to provide almost type classes to Kotlin. And if there is even one issue that if it's implemented, Kotlin will have quite okay type classes. So it's still evolving language. So it looks like Scala. It's not Scala, but it has some. They do some improvements to that, and it's quite successful at the moment already. Of course, it has great IDE support. If you don't know this, the Kotlin is basically implemented by JetBrains, the company behind IntelliJ. So it has great IDE support, of course. Google has already named it official language for Android last year in May. So it's like that was the great moment in Kotlin history. And Spring officially named it as the first class language, so they support it as well as Java. However, I must say in that case, because Kotlin is so similar, especially on type system, that to Java, basically they don't have much to do. They provide sometimes small libraries that let you use some Kotlin syntax sugar, but you don't have to do much really for that. So it costs nothing. So this code is exactly how, for instance, we code something in a real project. You see that's a real project because, for instance, I have magic 8 number here because it's some experiment. But you see this flat map to the madness because that's really, you have no for comprehension. You have some experiments here because of the failing failing part here because this is something that fails sometimes. So we have to parallel it. Okay, this is the code in Kotlin. And if you are a Scala developer, the only thing that's different is like This thing, because you would have underscore here in Scala, and here you would have a brace after the equa. Or you don't have to put bracket here. Okay, you don't have. So in Kotlin you don't have to either to put brace after that. Okay, so it's cool. It's more or less looks like Scala with some limitations. And how it was really like adopted. So I told you it's about lies. So basically, the thing is that I proposed first this Spring, because it's Spring, we already have Spring, so just new version of the problem. Then I proposed Kotlin. This was a discussion, and it was like accepted. I have a small team, but I'm discussing with more people. So basically, of course, you will see sometimes, oh, just okay, let's do it. You have indifference basically. So people just accept it, and then they do Java in Kotlin. It works. I have one very skeptical object-oriented guru. When he sees these flat maps, he always says we are crazy. And that's absolutely not a good code at all. Sometimes I'm thinking maybe he's right, but okay. And of course, that's the best story. I have enthusiasts. One of the junior developers is very enthusiastic about it. And however, I wouldn't call him junior. He was really, really good already at functional programming, but he never knew that. That's funny because really Kotlin let him really his talents explode. That is the thing that's really great. So he's helping me a lot in development, in making this code cleaner and better. So this is really something that I love. The language, if you have a little bit language, you can be way better developer in terms of what code you produce. And even I see the changes because we work both we have different projects. I see now changes in a Java project because the same ways we do Kotlin code are now more or less implemented even in Java part. We are crying doing this Java, but it's still better and more functional. So, however, we have some funny limitations. At the beginning, I told you that, for instance, we have Java EE deployment. At the moment, company is changing that, we have Java EE deployment. So, how can you even put that inside of the application container? If basically Spring Web Flux, you have to start with a main, you would have to put jar, and typically you would start on Docker or something like that. But you can do that. So you can still put a wrapper with a classical router, a controller, REST controller in Spring on top of your code, and it now works with Flux and etc. So basically, it's not. I was surprised that this ugly deployment as war is still not that bad, and we didn't have to do much to support it. Of course, then application starts way slower. However, it's not. It can be non-blocking, but not in our case. We use JBoss, but okay. It can be even with this REST. You can do non-blocking if you use special appropriate application server. So it's ugly, but it works. It's safer. So, however, that's funny thing. I have a competition with this Kotlin approach. Who knows what else in Java world provides you more or less the same syntax sugar as Kotlin? No, not very. No, those are immutable collections that I'm using even with Kotlin. I'm talking about the language. Lombok, I've heard this exactly. So I have a lot of Lombok discussions, especially one bank I'm working for. People they want to do Java because they know Java, so they want to stay with Java. They don't want to spend this 15 minutes to learn Kotlin. Let's do Lombok. So I will show you Lombok. Why I hate it. So basically, it's a behavior like we will do a new language, but we pretend we don't do that. So because that's how the Lombok code looks like. You have annotations, and this example is very very straightforward. I've seen the Lombok classes with so many annotations, and even it supports val, and basically a lot of stuff you have in Kotlin is supported by Lombok. But it looks like that. Annotations, then you put annotations here and there and there. It's like I was in a heavy Lombok project, and it was ugly. And the thing is, isn't that the new language? Because it is Java, but if you have vowels here, come on, it's not anymore. So the thing is that's my table, like Kotlin versus Lombok. It's, by the way, Kotlin is a little bit richer. Okay, a little bit is like not fully set. It has more stuff than Lombok has, but Lombok has all this most important, that I have to admit. But both are, in fact, things you have to learn. And both need compiler plugin for the build. Both need IDE support, which is exactly quite okay in both cases for Eclipse and IntelliJ. It just works without any problems. However, Kotlin would have like spent 15 minutes and 30 seconds to learn, which is like too much for some people. Where while in Lombok it's like 8 seconds less, so it's like huge change. Yes, and the Kotlin is this is the most important part. The Kotlin is, I would say even that compared to Scala, Kotlin is well-designed language. They were seeing the parts where Scala was like not that elegant. So Kotlin as a language, even though it's limited, and maybe because it's limited, I have to say, and I don't even like Kotlin that much being a Scala fine, but it's very elegant, really. It's like, it's minimal to some extent. However, Lombok, it's like every time I see Lombok, like my eyes are bleeding, really. This is that. So the conclusion of this talk, so I made it quick. That's good, because I wanted you to tell only some lies, practical lies, how you should lie. Conclusion is, we did only 2 steps. Both were small. We changed the Spring to the new version. We used the subset of Spring. So not a big deal. It was accepted. With only this thing, we are previously doing that, it's not enough to really embrace the functional programming, because your language isn't that cool. So the second step was to choose Kotlin. And I wasn't sure if it's so good, if it really changed. Maybe it's just a little bit better Java. And I was skeptical to Kotlin. But the practical conclusion was, it really changed completely the way we programmed. So the code base I'm talking right now from the project, it was recently I found that we have only one variable. So all the things are really immutable. That's partially a trick, of course, but it is. And this one variable, even recently, I completely eliminated. We have now code that looks totally immutable. It's really like that. So we have only vals, and it's really project processing tons of PDFs, etc. So it's all, however, not a big project with tons of services. Basically, it has one service. We've eliminated magic, so now we have a lot of tests, but those tests are meaningful. So I completely trust them, because compiler says it will be always compiled to the same code. If there is, we don't use database transactions, we don't use databases there yet, but if there is some aspect here like checking of security, it always works. And basically this means we eliminated mutability. We have really a joy of this functional programming. So this is the thing I was skeptical, because again, this is not Scala, but it's enough to make our life like more fun. Really see the power. We don't have one thing in a Kotlin. Basically, type level programming is not existing there, whatever. But it's still complicated. I'm not really using that much in Scala, so for me, it's just good enough, really. And it was like accepted, because from the outside, from the management point of view, just do two small steps. However, no normal Java developer would recognize what we do in the code, because it's now totally different. Okay, so yeah, that's my conclusion. And like, if there are questions, that's the end of my talk. I have a couple of minutes, so okay. At the beginning. Okay, so that's it. How do I do transactions without using annotations? So this is recently, like 5 days ago, I had a talk especially about that in Warsaw. So how you practically can do that? So now first answer, which is sounds cool, is transaction monad. But reality, I don't use transaction monad, never. Basically, I only use it in examples for, because it looks fun. So how do I use it in practice? High order function. You have doing transaction. It's really easy to see. Doing transaction, then you take argument, which is a function that takes like database connection or session, whatever, and does the stuff. And that's it. Inside of this one written function, you have begin, commit, everything. You can even stack it with different aspects. It's possible. In Kotlin, you don't have monad transformers, but it's but you have to manually stack it. But it works, and there is even library for databases called Juke. Who knows Juke? It's for Java. It basically already had this function written for you. Do in transaction, and you do it. And it's great because it works always, not only on tests. Always also on production, which is cool. Okay. Other question? Oh, there is a question.
Yeah, hi. I have a question. Why do you think that Magic is gaining more popularity, like Spring Boot and Spring Data, but we know that it's adding more issues?
So why is the magic in Java, the Spring Boot especially? I know the Spring Boot very well from the problems. Why it became so popular and why it's even now becoming more popular? I know the answer, I think. When I was learning programming, my first language was BASIC. Who knows BASIC? It's a cool language. Basically, if you have beginner, you want to, even today, if I wanted to impress you with some things like showing cool animation on stage, I could do that perfectly in a couple of lines with Java. The other language which is so cool in impressing people, it's a JavaScript, for instance. So there are languages that let you do couple of great things in a couple of lines. The problem is you can't reason locally. So in BASIC, if you have an error and you look for error, you basically have to look whole code. In functional language, if you have error, you typically can eliminate it to one function. In object-oriented, to one class. But if you have magic, you have to see all the jars that you have in the code. So while your program is still small, it impresses people. You only see the problems while you work with a team like 8 people for a couple of months, and then one day someone adds something to your project like third-party jar, one aspect, and after a week, not instantly, something fails on production and nobody knows, and then the development is stopped for 2 days or 3 days or even more, and you look for like magician, whatever, to solve the problem, but you pay it way, way later. So at the beginning, everybody is impressed by the magic. It's just like this. As long as your code base is small, it's great. Okay, a question there.
Do you think it would be possible to take another step? I mean, with the client, to convince them to take another small step to replace, for example, Kotlin with Scala, or or maybe the other part with Aka.
So I work for different customers, different clients. So I can say that because of the bad marketing of Scala, it would be hard. I'm not hoping. Okay, I'm looking for developers' perspective for my developers in the team. I think that Kotlin is a kind of a gateway drug. If they learn Kotlin, they will see that it misses some features that they will want to use Scala. From the perspective of what we will be using on production, I think the Kotlin will evolve and will be slowly taking more and more features, because we can request what we want in Kotlin, and people are doing that. And it will become more and more sophisticated to the moment that it will be almost Scala. So I see it that I think that will probably happen first. Then I will see more customers using Scala, because it's like in my business especially. So even those big banks are using Scala a lot. But they use it for big data, but they don't use it for instance, these typical web projects where it also perfectly fits. Just it has some niche, but it's not widely used. And basically, I have like big architects telling me, no, you are just not allowed, and I basically can do nothing. So that's the only way is doing small steps. And yeah. Okay, no more questions? Great. Oh, there is a question. Okay, why is the thing optional in Java is broken? Because this one guy, I won't call his name, but it's on B, he exactly even stated that Java should never be a functional language. And because of that, some things are limited. one thing that is limited is exactly the optional. In Java, for instance, it's not serializable. It's not. So you can't use it as a field. So you can't have in your class field that it's optional because you wouldn't be able to serialize it. Sometimes you have to. So, and even you have warnings in IDEs that you can only use optional as return of method, not as an argument. Why? I have optional arguments. That's normal for me. But so because of that, I'm using option from Waiver, which basically has no limitations, is serializable, has better API. So API of optional on Java is not that broken, but it's the option from Wave is more consistent with the rest of the monads, like they are provided there with the lists and everything. So because of that, I like it more. Okay. Okay, unfortunately, we are out of time. So if you have more questions, I will be on the table down there.